Hello, good afternoon. My name is Angel Borasin. I'm studying of mechanical engineer. I'm fifth semester. This video is for the signature of mechanical fluids. Then we're going to talk about a topic that is property of fluids. So for this video, we're going to have a review of all different parts of this topic. So this topic is so extensive, but we're going to try to in a short time. Also mention that this is for the teacher that is in charge of the assignment, that is Hector Augusto Dusan. So, well, let's go ahead. We're gonna have to talk about the property of fluids. So the first thing we have in this part is that we have to speak about something general about the property of fluids. So that is something that is have a lot of big application in the industry. So, well, with a specific focus of fluid mechanics, we can include about the distinction between compressed or non-compressible fluids, also the surface tension, capillarity, and we're all about that. We're going to talk about is using the water of reference, um, and different kind of things. So we also have some properties of the fluids that we have, for example, the viscosity. This one refers to the fluid's resistance to the formation of certain rate. In a simple terms, it measures how sticky or sticky fluid is. For example, maybe the viscosity for the water is less than for the oil. So, sometimes it happens. The more part of the viscosity, we can see that part in the oils specific now we're talking about maybe mechanics on engines or something like that. It is so important this part. Also we have about the density. This is mass per unit volume of substance, which determines if its weight or abundance of a fluid. So for example, it would be also use the most common one, that is the water, that is 1,000 kilograms per meter cubic meter, sorry. Yes, something like that. There is some terms that we have already managed about that. Also, we have the pressure. So fluid sports experience different kind of pressure in all directions, which transmit eventually through the fluid. So these properties are crucial in understanding fluid behavior in a confined spaces. So in this part, we're going about like later when we talk about the compressible and non-compressible fluids, we're going to analyze what that means because with that terminology, it's not the best. So, well, next, let me go 1 second. We have the difference between compressible and non-compressible fluids. So, well, in this part, we have that fluids can be broadly categorized into compressible and non-compressible fluids, based on the ability that they have to change their volume under the pressure. I mean, this is like depending on fluids are compressible or not. We're going to analyze which ones. For example, in general, we what divide into categories, that is gases and liquids. So, for example, the compressible fluids, like I mentioned, are the gases. So, gases can be compressed under density and can be altered significantly by application of pressure. This property allows them to be stored in tanks of this and use of various applications such as pneumatic system or air compression. For example, maybe the Helio is a good example of how what we can do. We have like a bottle of Helio that I use for the gloves, so it's for the kids. So this is a good example of that. We can compress that in such a little space. Also, we have the non-compressible fluids. That in this case is liquids. Liquids such as water are considered non-compressible as the volume cannot be significantly reduced by the application of pressure. This property might then idea for hydraulic systems and compressible fluid dynamics. What that means that, for example, we have the water, but even if we put that water in a, for example, in a boil or a bottle, we under pressure, the water is not going to be reduce the volume. It's going to look for a way that can escape, be free and adapt to the form. It's not going to be compressible or something like that. Well, what else? Well, we have analyzed that. Also, we have the surface tension. Okay, that is so interesting. So the surface tension is a property of liquids that are arises from the cohesive force between molecules and surface of the liquid. This creates an effect that is the surface of the liquids behave like a stretched elastic membrane. Water being a non-compressible fluid achieves a notable surface tension, which gives rise to phenomena such as the formation or doublets of the ability of certain instance to work on the water. This we can be more explained like we saw in a previous class. That is more like when the forces, the different quantity of forces and different directions, we analyze like a vectors under the water. So in the final, in the top of that, we can see that the forces are more like established, is more equal. So it will make like a summatory of the forces there will have to be zero. So it is going to be relaxed. So for example, that we can see that some mosquitoes are able to walk into the water, and due to the surface tension is enough to support that pressure in some way. We can analyze that. Also, yes, so that we can like, for example, also we have some other topic that is the capillarity of the fluid. So, well, a capillarity. Capillarity refers to the ability of liquid to flow narrow spaces without the assistance or even opposition of external forces like gravity. This phenomenon is particularly used in non-compressible fluids like water, where they allows water to move forward through narrow tubes such as tiny valves in plants due to the combined effects of the effects and cohesive forces. Well, this is not there is a technical explanation that we have here, something like that, but well, giving you more like an example, is could be like more the capacity to have a fluid to go up just in a capillary way, as for we can say that. So it is like the ability to have a fluid to go up without necessity of external force, just by maybe we can analyze like the normal contours that is in the nature, nothing external, nothing like a compressor, nothing like pressure, hydraulic, or nothing like that. There is ability to have different kind of liquids. Even as that, we analyze that all different kind of liquids have a different coefficient of that. It's different from the water, from the oil, or from the maybe from the gasoline, also maybe from the for a UV something. Everything is different. So there is a we are going to analyze a different kind of that with the pass of the time or during this signature. Well, in conclusion, we have that the properties of the fluids. So let me check here. So well, property of fluids. So we can conclude that we analyze the compressive or non-compressive are different. We can analyze that we're going to manage how for this signature more than non-compressible fluids due to our more dedicated to the part that we analyze in this signature that is mechanical fluids. Sometimes, of course, we're going to analyze some compressible fluids, like some gases, but that will maybe just a part of our system. But the main that we're going to use is the non-compressible fluids due to plays a most important role here. So we can understand that all of these comportation of the fluids, these properties is more important from the engineer. Also, we can analyze like some physics, biology, or different kind of things, but taking that from the engineer is the most important thing. So this is such a good example to manage these situations. So all in here, it is a perfect way. So there is a reason that we're studying here, that's here. So, well, I consider that that should be enough information for now. This is just like a little introduction about this property of the fluids. So, well, I really appreciate your time. Also, I really hope you have a good rest of the day, such a good big star. So, thank you for your passion and see you in the next time. Bye bye.